Hey guys, welcome back to our second video now. So if you were absent and you're tuning in to get caught up, we missed you in class today. If you're just watching to get some review, I hope this video helps you with that. So the first thing that we're going to do is talk about our essential question. Every section that we have will have an essential question. That means it's going to be a question that tells us what's the goal of doing all this math. So the essential question is, how do you create equations and use them to solve problems? So, a couple things that may come to your mind when you think about that is we probably want to make sure we notice patterns. So if you're given a bunch of things, you may want to notice a pattern. A pattern may help us be able to create an equation. Well, when it comes to solving equations, we know to get x by itself. So get x alone. Okay, when it comes to creating an equation, we need to know to define our x. So let's define x. How do we solve equations? Well, someone mentioned that we use PEMDAS backwards. Okay, and of course we have our golden rule of algebra, which is what you do to one side, you do to the other. Finally, we can use what we learned in the last section using our properties of equality. I'm going to write that as prop of equal, because I don't want to write it all the way out. And then finally, combining like terms. So there's probably many more that you can come up with, but these right here are the most common ways that we can create equations and use them to solve problems. And that's exactly what we're going to do in this section. So first things first, let's take a look at our vocabulary. The first thing we have is equation. So what is an equation? It's a statement that values two expressions as equivalent. If you want a little bit more about this and exactly how to recognize equations, take a look at the last video or look back in your notes from the last section. What's a variable? It's a symbol or letter. We usually use the letter X, but any letter can do. That represents an unknown number. Okay? What does it mean to isolate? Well, we're going to use both the properties of equality and inverses to get the variable on one side of the equation. So, using the properties of equality, I'm going to put prop of equal and inverse operations. We get variable alone on one side of the equation. I'm going to put EQN to stand for our equation. Okay, so we talked about inverse operations, but what exactly are inverse operations? They're operations that undo one another. So what's an example of an operation that undoes one another? Well, let's take a look. If I am adding 7, then if I subtract 7, that undoes it, right? If I have x plus 7 and I want to get x by itself, then I'm going to do the opposite and subtract 7 on both sides. So you guys have worked with inverse operations before. We're just working on it. A little bit different now. Okay, solutions to an equation. A solution to an equation is going to be any value or number or values, because sometimes we'll have multiple x's that work, that make an equation true. Again, I used EQN to say equation. And last, but certainly never least, equivalent equations. Equivalent equations are going to be equations that have the same solution. So equations that have the same solution. So sometimes you're going to get equations that are going to be very similar. They're going to have the same solution. So we're going to call those equivalent. So we just had a lot of fun with some new vocab words. Now let's put those vocab words into practice. Let's use our vocab words to fill in our blanks here. Let me fix that. It says, explain the process for solving the equation x plus 2 equals 8. So I'm going to highlight that so we know that's our big deal, using the vocabulary below. So we're going to solve it by talking through what's going on. So to solve the equation x plus 2 equals 8, we have to blank the blank x. Well, if we look back at our page, we know that we had the word isolate. So we want to isolate the variable x. So whenever you're solving equations, think x needs to be alone. Get x alone. How are we going to isolate it? By using the inverse operation of addition. What is the inverse operation of addition? Well, inverse operation just means do the opposite. So the inverse operation is subtract. So we are going to subtract 2 from each side of the equation. So the original equation, x plus 2 equals 8, and the equation x plus 2 minus 2 equals 8 minus 2. So notice we have to subtract 2 on both sides. I'm going to circle that just to point it out. Are equivalent equations, meaning that both of these will give the same answer. So equivalent equations. I'm running out of room, so I'm going to put EQNS. So the blank is x equals 6. That is our solution. So there's not going to be a lot of times that I require you to fill in the blank, but if I was to ask you to explain how you solved it, I want you to use the vocabulary that we've built in our mathematical toolbox. Alright, so the best way to get started with solving equations is just to jump right in. The first thing that I'm going to really throw out there and point to you is that, remember, we said we have to do PEMDAS backwards. So we are SAD-MEPing. We're going to deal with anything that's got subtraction and addition first, then we're going to do some division and multiplication, and then we would deal with exponents and parentheses last in our goal to get our variable by itself. So, we want to solve the following two-step equation for the variable b. We'll take a look at it. We've got b all by itself. Or we want to get it all by itself, but what's bothering it? well, it looks like it's got being multiplied by a -3, and it's got a 69 that we're adding to it. Because anytime we have 69 minus 3b, we can write that as -3b plus 69. Well, since 69 is being added, what's the inverse? What's the opposite? How do we make no 69s on this side? Well, we would subtract. So, we're going to subtract 69. But what we do to one side, we have to do to the other. So, we're going to subtract 69 on this side too. Because if we don't subtract it on both, it's no longer equal. When we subtract 69 here, it goes away. I like to put a little slash through it to remind me, hey, bye-bye, you're going away. Bring down the -3b, because we didn't use that. And so we have 48 minus 69, which gives us a -21. All right, the -3 is still bothering our b. We want him to be all alone. So, what do? Well, we divide. Since it's being multiplied, we are going to do the opposite, the inverse operation, and we are going to divide. When this happens, that gives us a 1b, so we can just write that as b, equals -21 divided by -3 is 7. Alrighty. So, the subtraction property of equality is what allows us to subtract on both sides, and it'd still be okay. The division property of equality here is what allows us to be able to divide on both sides and be able to figure out our equation. Does this make sense? Alrighty. So we get that our answer is b equals 7. If you are watching this video, we're going to skip this section here about the virtual nerd video. If you want to watch that video, just let me know. But what this video does is just quickly review what I just did up there, showing you a differing way to do it, and I have you write down something you learned if you were in class. So don't worry about this section if you are watching the video and you were absent. Well, there you go. Let's turn the page. Alrighty, that's a much harder one, isn't it? We've got what is the value of x in the equation? 2 times x plus 4 over 3 minus 8 equals 32. There's a lot going on there. So there are 2 ways that we can tackle this. The first way is just to go ahead and just try to get x by itself by just subtracting. So I'm going to show you way 1. So first things first, the first step to solving any equation is rewriting the problem. So remember, we're sad mapping. Let me pull this up just a little. We are sad mapping, so that means that we're always going to do subtraction and addition first. Well, look, we've got this minus 8 here. So what we're going to do is we're going to add 8 to both sides. This gets rid of that, right? So we have 2 times x plus 4 in parentheses, all over 3. We leave it there because we haven't done anything with it, equals, well, what is 32 plus 8? That gives us 40. Alrighty. Another way, now what we got to do is, we've got some dividing, we've got some multiplying, and then we've got x being bothered by something in parentheses. Well, since we've got division bothering it, we can take care of that first. So, let's multiply by 3 on both sides. What happens if I multiply by 3 on this side? Well, notice the 3's are going to cancel, leaving us with just 2 times x plus 4. Well, what is 40 times 3? 120. Okay, so our x is now being bothered by both the 2 and the 4. But before we can even start to deal with what's inside the parentheses, we got to get rid of this 2 that's bothering it all, right? So since the 2 is being multiplied, our inverse operation here would be to divide. When we divide, that cancels. leaving us now with our x plus 4. We can pull her out of the parentheses. Yay! 120 divided by 2 is 60. Now the last thing to do to figure out what our magic number, our solution with x is just to subtract. So if we subtract 4, we get rid of it on this side, and we get x is equal to 56. So that is the first way to solve it. It's a wonderful way to do it. The other way we could do it gets rid of our fractions. And I know how we are about fractions. We do not like our fractions. So let's try it in a way that makes it easier so we don't have to deal with the 2 over 3. First step is always to rewrite the problem. Okay, we've rewritten the problem. If you ever want to get rid of a fraction, you want to multiply by the denominator all the way across. So we have this, and we want to multiply by 3 to every single part of the equation. So 3 times 2 over x plus 4 over 3 cancels out our 3's here, and leaves us with 2 times x plus 4. That's our goal. We wanted to get rid of our 3, right? Negative 8 times 3 gives us negative 24. And then 32 times 3 gives us 96. We might choose to go ahead and get rid of our fraction because this looks like a much easier thing to solve than remembering to multiply by our 3 when we're dealing with a fraction. Either way you choose to solve it is fine because as you're about to see, we're going to end up with the same answer. So we're going to add 24 and add 24. We want to get rid of it over here. That's going to give us 2 times x plus 4 is equal to 96 plus 24, which is going to give me 96, 24, 10, 11, 12, 120. Then, what are we going to do? We're going to divide by 2. And last, but certainly never least, our 2's are going to cancel, leaving us with an x plus 4 is equal to 60. And then we are going to subtract 4 on both sides. And we end up with the same answer, that our x is equal to 56. Alrighty. In class, I had them work through this problem here, the solve the equation on your own. I'm not going to work it out in this video, but this will always be in the section, like the binder in the front, if you want to look at it on your own and see what it looks like. It'll also be worked out in our OneNote. So if you need any help with that, if you want to try it on your own and see if you get it, let me know. But we're not going to work that one out for this one. Alright. So what I want to do is work out 2 more problems. We're not going to do number 1, but we are going to look at number 2 and 3 in this video. You will always have access to how number 1 was solved if you look in your binder in class or you look on the OneNote. But remember, I told you I was trying to keep these videos less than 30 minutes, and we're already at 20. So I want to work through number 2 and 3 with you so you have examples of these types of problems. So look at number 2. It gives us 15 minus 2 times 3 minus 2x in parentheses equals 46. There is a lot going on there in order to solve. So I want to know, well, what do we do? Well, first step is to rewrite the equation. Okay, we got that first step out the way. We rewrote that equation. Now, notice, our goal is to get our x all alone. So what we can do is we can subtract 15 on both sides. Because remember, we always want to deal with our spare and out there numbers first. If we do that, we're going to end up bringing down our -2 times our parentheses, 3 minus 2x, equals 46 minus 15 is 31. Alrighty. What can we do now? What happens? Well, there are two options here. We can divide by -2 on each side and just keep going. But if we do that, we're going to bring ourselves into that nasty fraction situation. And we don't want that. So, what I recommend doing is using our beautiful distribution property. So, -2 times 3 is -6. -2 times -2x is positive 4x. And all of that equals 31. Notice that this is a lot easier to deal with than the fraction 31 over -2, since 31 doesn't evenly divide with 2. Now to get x by itself, we add 6. Bring down your 4x, because you didn't do anything with him. And then you do 31 plus 6, which is 37. Now we can avoid our fraction. But if there are ways to avoid your fractions, I absolutely recommend you do. So now we divide by 4 because we have to get our x by itself. And since I'm running out of room, I'm going to arrow it over here. Whee! And we end up with our x is equal to 37 over 4. I don't mind you leaving it as 37 over 4 because there's just not a nice simple way that's going to break down. If you wanted to write it as the decimal form, that's fine, but I'm going to leave them as fractions usually. Alright, let's look at our last problem that I want to do in this video, and then you guys have learned the first part of section 1-2, which is solving linear equations. Then we're going to play with word problems in our next video. So look at this. Look at our wonderful problem here. We got bunches and bunches of fractions. Woo! Galore. So, there are two ways to solve. We can deal with the fractions. Fractions are not meanie weenies. We can do them. So, let's do the first way, just dealing with the fractions. First step, rewrite the problem. I'm going to call this way 1 because I forgot to write it above it. Okay, well, 2 over 5 is just a number. So we're just going to add 2 over 5 to both sides. Well, then we have 2 over 3y, because we bring it down, is equal to 5 plus 2 over 5. In order to do that, we've got to do some fraction math, but we can do that, and we will end up with 27 over 5. Okay. Now, what are we going to do here? We've got 2 over 3y. In order to get rid of a fraction, multiply by its reciprocal. 3 over 2. Notice that the 3's will cancel, the 2's will cancel, leaving you just with y equals. And then we're going to come over here and multiply by 3 over 2. Well, 27 times 3 is 81. And 5 times 2 is 10. So your answer is 81 over 10. So at this point, I'm probably guessing you guys did not enjoy all that fraction math. That is why I recommend doing it by way 2. Way 2 gets rid of all those fractions, so you have an easier problem to deal with. So, first things first, rewrite that problem. So, when you have two fractions, you want to multiply by the greatest common factor, the GCF. Something that both of your denominators will both go into. So, the biggest number I can think of that will both have 3 and 5 go into them is 15. So when you multiply by 15, you want to multiply by the entire equation like we did before. So you want to do 15 times 2 over 3y, 15 times negative 2 over 5, and 15 times 5. So 15 times 2 over 3y. That is going to give us, well, what's 15 times 2? That's 30. Divided by 3 gives us 10. So that's 10y. Okay, now let's take care of the next one. 15 times 2 is 30. Divided by 5 is negative 6. And then 15 times 5 is 75. Notice that this right here is a much easier problem to work with than this right here, playing with our fractions. So now what do? Well, we add 6 on both sides. Then we have 10y equals 75 plus 6, which is 81. And then to get y by itself, we divide by 10. Divide by 10. Woo! Get y is equal to 81 over 10. So, yeah, we got some ugly answers, some ugly fractions, but we're okay with fractions. The easiest way to get it is to get rid of them in the beginning, so if you don't like doing addition and subtraction and multiplying and dividing fractions, get rid of them in the start. But either way you do it, notice they both come up with the same answer. Alright, that's all I got for you in this video. You'll notice that it says class activity here. That is your homework that goes along with this. I'm going to give you guys time in class to do it, but if you don't finish it, it'll be homework. If you were absent, this is your assignment. This video and all the notes that you have should help you with that. Alright, y'all have a great day. Until next time when we tackle word problems with equations. Yay!